have a chair here. Olga, we have a chair here.
Yeah, but it's much better to see from here.
Okay. Okay. Good. Thank you very much, Mr. Moser. Thank you very much, Mrs. Sabu. You will find some parallels between our talks because Logicals, as you might have seen, is one of the companies involved in the Christian Doppler laboratory. And what I will be talking about has been researched on in this laboratory as well in the recent years. I will talk about the integration platform AML Hub. Mrs. Sabu mentioned it already. And about how it can be used in creating linked plant models to support engineering and operation for Industrie 4.0. I've been informed by Mrs. Vogelheiser-Busch from Technical University of Munich that that term must not be translated because it's a German term, and she has been very strict about this. But I will try to conform to this. That's a quote of Wolfgang Sitz. He's from Magna Steyr, and he said it in First of July some weeks ago. And he said that they, as a producer of car components, had no alternative to jumping on the bandwagon Industry 4.0 because they were not allowed to do any more prototype production, but they had to virtualize this. So product development has gone virtual, and in parallel the plant is engineered and the virtual factory is dimensioned. And what you can see from this is that he's just talking about engineering. He's not talking about what happens when all is running, when all the components in the cyber-physical systems are interconnected and talking to each other and understanding each other. But at the beginning, there is engineering. And that's our conviction as well, that Industry 4.0 starts with engineering. That might be a reason that our company, let me say some words about it, is a company developing engineering tools for the automation, for industrial automation, for different domains from steel mill to large boats or hydropower plants. We are quite proud that one of 3 hydropower plants worldwide is engineered with our engineering software. And we have different software for different tasks in the automation engineering. I will not go deeply into this, but there are a lot of tasks. Some of them are tasks where our systems, like our programming system, the core product, is used, or the documentation system, or the runtime system for controllers. But there are a lot of other tasks where we are not involved. But as we have seen from the recent years, and our company exists now nearly 30 years, the engineers have to deal with all these other tasks, and they are using tools in these other tasks, and they are producing data and plans and design documents which have been reused in other tasks and have to be used by other domain specialists. And that's why we have started now 6 years ago this Christian Doppler laboratory, where the Automation ML Hub or the Automation Service Bus, previous version of it, had been developed. It's just an integration platform. Integration platform for heterogeneous tool landscapes in the automation field. And we are quite sure that for the years coming, the heterogeneity will not go down in this issue. There is heterogeneity between the domain of electrical and mechanical engineering, and heterogeneity between different vendors. And that will continue. And that was the reason why we saw a need for this integration platform, and it maps quite well for the Industry 4.0 trend, which is now coming. And what we see and what we are committed as well is that Industry 4.0 needs processable and linkable plant models. Because, as we have heard earlier, the context is absolutely important. If we have got cyber-physical production systems or things in the Internet of Things world, they have to provide the context of their of themselves to be able to communicate to each other. And the basis to provide the context, or to provide this context, can be a plant model. And for complex plants, it is not possible to engineer this plant model in addition to the engineering process, because intrinsically it is coming into existence during the engineering process. I will go deeper into this later on. I'm then coming to automation ML as well. As I've seen, it's not so widespread in this here in this room. Just to say a few words about it, it seems to be suitable for a suitable standard for plant models, but it needs an integration platform, an infrastructure to integrate the software tools working with automation ML to build the plant model. And as a conclusion, we are saying that the integrated engineering tools networks are increasing the productivity for sure, with or without Industry 4.0, and build the basis for the semantic linking and the plant models. When we are looking onto, I've been talking about the different tasks in the engineering process. This is a picture based on work of Ulrich Epple, who is saying there are different value chains in the engineering, the planning and construction of plants. And the product and producing line, product line development, the process and plant development, production planning, plant construction and operation. And they are shown here on different floors, and that's the traditional way. The traditional way during planning and construction. We have the product development, we have the plant and process development, then the plant gets constructed, and that's it. And during operation, we have another picture. We have the plant, the production plant, we have the production itself, the pre-products, we have some maintenance, we have the product and the customers, if we have got some. But Ulrich Epple says, in the future we have to look on this together, because Industry 4.0 is much about flexibility, and a lot of tasks done here during the plant construction will have to be redone, maybe in a different way than today, to be able to provide this flexibility. If there are new requirements regarding the product, some tasks in this value chain have to be done. The plant has to be adapted, some construction has to be done, and so on. And that cannot be done in the way as it was during the last years, because that's not efficient enough. The customer expects faster speed and more flexibility in less time. And therefore, these tasks here have to be done in a more efficient way and without the media breaks which we are seeing today. We are seeing tools producing PDF files, and someone is reading this PDF file in the next step. That's not possible anymore. At least some of these data has to be passed in a processable way. So machines like Heinzelmännchen, you said, I don't know the word in English, Heinzelmännchen can do some of the work that has been done today by engineers. Especially this part, in this part are the tasks we are looking at, and we are saying that that's the central engineering tasks together with the operation, where different documents, different design documents and plans and programs and so on have to be provided in a different way than before. Let me come back to the VDE status report Industry 4.0 from July 2014. They said that there are 4 main research areas which have to be addressed to be able to fulfill the promises of Industry 4.0. The adaptation of the business IT, I will not go into this, but we have heard something about already. evolution of automation technology methodologies. The flexibility is not there today, so there has to be done a lot. Structural modification abilities during runtime. More flexibility of the production process needs more flexibility of the production system. And there has a lot to be done. But what we are talking about is this part here, because we are engineering tool guys. So the use of information from previous design phases, especially seamless models in engineering phases and an integrated tool chain. It is not there today. And that was also the reason why especially Daimler started with Automation ML. I skipped already some of the slides of Automation ML because Martha will talk about it. But the main issue is that Industry 4.0 components, cyber-physical production system components, or any production system components can be modeled as a mechatronic object with structure and behavioral model. That is what Automation ML is addressing. We have the plant structure, we have the functionality, we have the kinematics. We can build as well, like some of our partners are doing, virtual commissioning on Automation ML models for car production, for example. There's all the information in it, and that's why it is complex and the models can become huge. But it allows to do efforts which cannot be done today in the classical behavior or using Automation ML models. But these Automation ML models have to be built, and normally they are built. Okay, I will show this by different engineers in different domains. There's a mechanical engineer, there is an electrical engineer, and so on. They are all working with their tools which are appropriate for the specific tasks. And the main issue, the main task from Automation ML in the beginning was to be able to exchange data between these tools. Daimler said it is not possible that we are exporting from ePlan some lists and doing some Excel work in between to be able to import it in the software tool or in the mechanical tool. And so Automation ML came into existence as a pure data exchange format between engineering tools. But as you can see here, it is not possible to use this approach in a complex engineering environment. And that is where the Automation ML Hub jumps into it, because it says we have no possibility here to ensure the data consistency, because all these fragments of the Automation ML files are on the file system somewhere or in some emails. We cannot do any queries like Mrs. Sabu showed on the complete model, and it is not accessible. The integrated data here is not accessible on a project level or on a plant level, because both is important. We don't see any progress if there's only the data exchange between the different users. And that is where the requirements, as I said before, comes into the domain experts want to store their Automation ML files in a way that is reproducible and traceable, to have these versions, not only the fragments between the tools. We want to check consistency and query data across disciplines, and the view on the plant, and the view on the project is especially for the project manager important. He wants to see what's going on. If there is a way to see what data is exchanged between the different engineers, we can make estimations on the progress, we can identify risks, and we can improve the process itself. And therefore, to allow this, an open exchange and integration platform, the Automation ML Hub is required. What is the Automation ML Hub? It's an integration platform which provides a repository for the integrated Automation ML model, and which can be used to integrate, to exchange the data fragments from the different engineers. Every engineer is working in his own tool. He is exporting his view, his facet of the Automation ML model, the facet he is working on, the electrical plan or the layout plan or whatsoever, or the software PLC programmer, and he is giving it into the Automation ML hub, and allowing the Automation ML hub to integrate these fragments to an Automation ML model, allowing to propagate modifications, allowing to reuse data from the electrical plant. For example, the pins of the inputs and the outputs can be passed directly to the PLC programmer, and vice versa in the other direction as well. So I'm checking consistency and propagating modifications between these domains. But it's also possible to do some process analysis, engineering process analysis on this integrated Automation ML hub. It's quite important to see that there are different roles working with the Automation ML hub. The engineering is the basis, but as well EPC subcontractors or managers, customers, and IT systems administrators have to deal with the Automation ML hub, and that's only exemplary. But there are different tasks which have to be done by these different rules. When we have started with the integration of these Automation ML fragments, we are gaining some benefits. But based on the integrated Automation ML model, it's possible to build additional features and to extend the basic functions. For example, to check what has been done between week 1 and week 2. And not on the tool level, but on the plant level. Who has done modifications in which part of the plant? So we have delta views on the plant model itself, and the Automation ML hub allows this on a model object perspective. Access management for functions for the project consortium. It's often very important that not every consortium partner is seeing everything of the plant. That's quite important for secrets, which has one, and for and the Automation ML hub allows the restriction on the tasks and also on the granularity what can be seen by one of the consortium partners. The Automation ML standard has a concept called role classes, which provide the definition of a specific device. For example, a role class for measuring temperature, or a role class for a conveyor, or so on. And based on these role classes, there can be done a filtering, and based on the topology of the plant itself can be as well done a filtering. Definition of rules for linking, some aspect Mrs. Sabu addressed earlier. It's not always trivial to link the different facets together, because the names engineers are giving to their objects are not consistent over the plant. And therefore it has to be possible to define rules to derive the mapping from these rules. And that's as well possible, and some research has been done on this, and there has been progress made. For project manager, I said earlier, progress report, a dashboard showing hotspots in the plant, for example, or showing where a lot of data exchange has happened. It's important for our customers, for example, doing the hydropower plants, to see what amount of signals has been engineered in a specific time, because these signals are gaining a status from the beginning. There will be a temperature or pressure, oil pressure somewhere. And from one engineering step to the next, the status of this signal is modified. And this status affects as well what is allowed to be done in the engineering project with this signal. And so we can see on the amount of signals and their status engineered the progress in the project. Yeah, and as well, custom solution provider APIs are some very important thing to allow additional queries based on the IML analyzer or other approaches to export data and to extend the functionality. There are a lot of ideas. Okay, I think I will go over this as well. And come. to the benefits for the user organization when we are doing automation ML data management based on the automation ML hub. We have the overview of the version data, we have better coordination, we have support for efficient quality management and better basis for management decision making. I think the points have been mentioned already. Yeah, and now I will come to the question raised earlier in the next slide, because we should not look only on the engineering phase. In the beginning, the approach was to improve the engineering efficiency, to increase productivity during engineering, to allow doing these consistency checks, this data exchange, etc. But on the engineering phase I've been talking about, we have these different tools, and we have the possibility to add an RML analyzer to interconnect, to link this plant model with information from the semantic web. For example, E-class, Mrs. Sabu mentioned it, or other documents in the internet can be directly linked to model objects of the plant model in automation ML. But the model coming into existence during the initial engineering phase can be used during the production phase as well to augment the information coming from the plant. Because in the automation ML model, all the information is there about the electrical engineering, about the PLC programming, so we know which sensor is connected to which variable in the PLC, and we know as well the information, the context information of the internal PLC variables. So if we are getting a specific value from the target system, we can add the context, like it's been said by Mr. Hooper, in the automation ML hub. We can say that's a temperature, and it's scaled like this, and we can provide this enrich this augmented information in a OPC UA server, where not only the value from the PLC, but as well the context information is added. And that is, I think, addressing one of the questions raised. Yeah, you raised it. That's an aspect we are working on, and I think we will show in the next time. We'll be able to show something about this in the next time. So not only during engineering, but as well during production. And one very important thing is that if there's done modifications, these modifications of the plant can be based on the engineering knowledge integrated into automation and ML. So let me come to the end. Okay, that's the same on one slide. What we are trying is quite simple. We are trying to increase productivity by the means of storage of the files and automation ML data and efficient access to outside data using the approach Mrs. Sabu mentioned, by reuse of engineering data and so on. To promote collaboration, because the engineers are often working on their own problems and seldomly exchange data only once a week or once a month. If they have got a low-level integration possibility, this data exchange is coming into existence much more often and will happen more often, and allowing to ensure the consistency during these engineering phases. And to gain insight. I think that's the most important aspect, but it's more in the future, because this integrated plant model is nothing which has been existed in recent years and in the past, but based on these integrated plant models, there can be done a lot of aspects during engineering and during runtime as well. Okay. Thank you. If you have any questions, you can contact me or Professor Biffel from the CT laboratory, and I thank you for your attention.
Thank you, Mr. Steininger. Perhaps one very brief question, if there is any. If not, we can also do it later after at least one. I already asked my question.
Thank you very much.
Thank you. Okay, so now we are moving to the very short presentation section where we have colleagues here from different companies that are really briefly presenting their use cases for industry 4.0